So good afternoon one and all present over here. Welcome to the channel. Uh, this video is getting uploaded after a long duration. I was on a break. So I came across an interesting question from LeetCode today. This is a medium level question, but trust me, it's not medium. It is a tough level, and also it also requires a lot of intuition because this is a question where generally we do get confused between what to use, a join or a window function or a union. So it is a mixture of that kind of stuff. Um, Again, in today's discussion, we will be trying to solve the same question using pandas as well. So I already have solved it using the pandas, but let me just take it away so that we can resolve it again. Great. So without wasting the time, let's begin the problem. This question is all about, like, we have to find the people who have most friends and most friends number basically. So here is the table. Request accepted table is the name of the given table. Okay. The ID is the requester ID, acceptor ID, and date. As per this question, this time there is nothing to do with the date. As you can see here, like they haven't mentioned like within this specific date and all. So we are not going to touch this column, the accept date column. Rather, we will be proceeding ahead with remaining two features, basically remaining two columns, right? So one of the approach for this kind of question is like whenever we see this kind of question, so one thing that comes to the mind is what if we use a self join. So if you use a self join, then basically we are creating the same table next to this table, right? Now we can use the self join on the requester ID and the acceptor ID basically. So one will have few things, two will have few things, and three will again have the few things. So I tried it, but I also found a easier approach. So I will show you both the approach basically this time. So let me just quickly start doing with the self join as of now. Let's say this is R1 and we do the join again on the same table as R2. Okay, so we will be doing it on the, let's say, requester ID, right? So let's say R1 dot requester ID equals to R2 dot requester ID, right? And let's just run the table to see what are we going to get. So something this way the table has been showing to us, right? So this is the table which we got. Now the problem using the using the self join at this specific question is, see, if the requester has sent a request and acceptor number 3 has accepted request, that means it is I will say it is a kind of binomial feature. That means what? Like let's say 1 is friend of 3, which also means 3 is again friend of 1. So that is the problem which is happening over here. Now if I just do the count of requester ID and with respect to the acceptor ID, then what will happen? So 1 has arrived how many times? 1 2 3 4. So basically 4 acceptors will be there for the number 1, while 2 and 3 will have just 1. But if you see the case, actually 3 is having the higher number of volumes because it is again friend with 2, it is friend with 1, it is also friend with 4, while 1 is actually friend with 3, 1 is friend with 2, and again the same thing as repeated, and 2 is only friend with 3. So this is the fluctuation that you can observe in this current table. So how to solve this kind of stuff then? So I will suggest, like, without going for the self join over here, because it will become again too complex, because I don't know like how to proceed ahead in this kind of scenario. maybe there you can find some approach. Yeah, maybe you can find some approach. Otherwise, you can also go for another kind of approach, which is this way. Like what I am doing currently is, like, let's say select requester ID as ID, okay, and let's say acceptor ID as friend ID. Now what I can do is I can actually do this way, that union of the same thing, but I just interchange the requester ID with the acceptor ID and the acceptor ID with the requester ID. Now what will happen is I will get very small table this time. You can see what is going to happen. See this part. So this becomes quite convenient for me to do the group by thing and then solve the question. Either I can go for uh, a subquery at this point, like this way. So let's say select ID, comma, friend ID as num, because that is what is given in the output table, num, and we will take it from our this subquery table, and let's name this as k. So this part I am talking about. So I have just converted the whole thing into a specific thing, which is ID, and I'm just created this table. Now what I can do is I can actually do the count on this part. So let's say this, like, count friend ID as num and group by ID. So again I am just refreshing the same thing, and it again becomes a bit smaller. So this is one of the approach. Now basically I just need to show the highest one who has the most friend and most friends number. So this is most friend, the ID with the most friend, and this is the column that has the most number. So I just do it this way. So order by num in BESC and put a limit 1. So probably this is going to give me the correct answer, and if you just submit it, you can see the bits also this time. It is 99.36%. So this is like one of the approach which I prefer in this kind of scenario, where it is quite easy to get. Now, now let's say like you have someone from the interview round, like, who wants the candidate should filter it approximately, like all the dates should be okay. Let's say all the dates, like, okay, let's say the date is not equals to 8, because we have two rows where the date is 8 and we doesn't want that. So what I can do is, in each union I can actually put it this way, like except date, which is not equals to your 2016 0608, and the same line can be quoted here also, and I'm just trying it if it works or not. Yeah, it does work. So this is some kind of filter has happened where the date is not 8. So number 1 and this part has occurred. So yeah, this works with the date part also. I just tried it here. So great then. Now let's solve the same question using the pandas. So in the pandas, what we will do is we will be actually okay in your dashboard or the LeetCode table. Here you will not have RF. Here you will have this table name. Okay, this part will be there in your dashboard, but I have just changed my thing to RF so that it is easy for me to type. So I'm just creating it this way, like, let's say BF equals to, I'm creating the first data frame where I will be grouping it up, group by, I'll say this requester ID and I will count the acceptor ID. Okay, dot count dot reset index name equals to, let's say, k, and I shall show you how the output looks like. So basically I will have two tables now, sorry, two columns now, column number 1 and column number 2, but we also know that this is just from the end of the requester, not from the end of the acceptor. So we have to create another table now. So let's create that. Let's say df1 equals to, okay, I think I have copied that right now. So, and I will just interchange the IDs over here, right? And let me show you how does this part looks like now. So it is just the interchanged part. So you can see, if you are seeing from the acceptor's point of view, then number 3 is actually leading. And if you just count both the things, then again number 3 was leading, as you can see in the solution. So now let's say, like, let's create a final BF now. So final BF equals to, I use the concat function here, pd.concat concat of BF comma BF1. And let me show you how this data frame looks like now. So somewhere these data frames become this way. You get some nulls over here, you get some nulls over here as well. So this is how the current data frame is looking right now. Yeah. So what we can do is, so what I am saying is, like, what we can do is, now let's take this concatenating out as of now, and let's just focus on this part. So we have created a table, right? That is the DF part, where we have taken the requester ID, acceptor ID, and so on. Now, what if we actually rename the requester ID, this part of the column? See, because my DF is this now, so that if you get confused, let me show you this way. So this is what my DF is currently. So what I will do firstly is, I will just take the requester ID and I will simply name it as ID this time. Okay. So basically I will just say it that df dot rename. Okay, columns, rename is the function I am using. Columns, I open a dictionary, I say requester ID becomes my ID, and I just show you what does this reflect, how does this reflect to the first data frame. You can see here now it has become the ID. Okay, the same thing I am going to do with df1 also. It is just that here we are not going to take the requester ID, here we are going to take the acceptor ID. Now you can see. Now let's just do the concatenating thing. So final df equals to pd dot concat, and it should be on df comma df1, and I will also show you how does my final df look like. This part. So actually we got that part right. So at this point what I can do is result equals to final df dot group by id The aggregated column will be k dot. Um, Basically, we can just count. So if I just count, then probably I won't get. Let's just do the sum. Okay. Dot reset index name equals to num. And let me show you how does this looks like now. This part. So we got the final part. This is what the columns, and this is how it should be. So we just need to do the filtration on this part. So let's do the just the ascending and descending things. So the result dot sort values is the function which we can use by column will be num, where ascending will be false. And since I just need to show the first one, so I just say dot head one. It is working perfectly. So let's just submit that. So basically, if I just give you a recall what we did. So we did nothing. We just did a group by with the requester ID and acceptor ID. We counted them. We had the common column name. We had given as purpose. We have given this name as K over here. So that again in the later stage, see if I just give it M, and then if I just do concat, then the same thing will happen. One column will be K, one column will be M, and the blanks will have the nulls. To avoid all those kind of extra step, and okay, if you do that way, again at the end also you have to convert your any one column name to the num or any single parameter, basically a single alias name, so that you get less number of extra column or less number of not required data. This is how we have to solve the question. So we got this df. It was quite simple. You just use a count function. Then I did a rename of requester ID, which is the first column that I have taken to ID. I have renamed the acceptor again to the ID, and then we have just worked on this part. Hope that you like this approach. If you have some better approach, and if I just submit it, then let's see what is the bit rate we are getting. Yeah, it's coming around 88.79%. Yeah. So yeah, that's all from my end, and have a great day. Hope you have liked this video, and please do like, share the channel. More videos are in the rows. Again, tomorrow we come with another video where we will be solving this kind of confusing question, that is investment in 2016. Again, a tough question in both pandas and SQL method. So have a great day. The video will be uploaded in quite some time, by evening probably. So please do like, share this channel, subscribe the thing, and be connected to watch more. Have a great day. Bye.